In chapter P5, we'll be getting into polynomials and then certain operations with polynomials. So for the definition of what a polynomial actually is, so this form is going to look pretty confusing, but this is the kind of technical definition for it. A sub n x to the n plus a sub n minus 1 times x to the n minus 1 and so on. So all this really means is that all exponents on the variable are whole numbers, and all the coefficients, which are the a values, are just real numbers. All of the terms here are separated by addition also. The polynomial is going to be of degree n, which is just the largest exponent. The a sub n, so the coefficient on the term with the largest exponent is called the leading coefficient. The term without an exponent is just called the constant term. And standard form is going to be written is written when the exponents are written in descending order. So for some examples here, for polynomials, something like 2x cubed minus 4x squared plus x minus 7. So all the coefficients are real numbers separated by addition. So it looks like it's separated by subtraction. But just remember, you could write something like a minus b as a plus negative b, so it's the same thing in this context. So the degree of this polynomial, and just also notice that all of the exponents are whole numbers. So the degree of this polynomial is degree 3, because that's the largest exponent. It's written in standard form also. Something like negative 15x to the 12th. Plus 3x to the 8th minus x. So this is a polynomial also. It is a degree 12 polynomial because of that exponent. Once again, notice the positive whole numbers for exponents here. And the last one here that I'll put is radical 3 times x to the 47th. So this is going to be a degree 47 polynomial, which is pretty large. But there's only one term here, but that's okay. It's still a polynomial. Radical 3 is a real number, so that is also a polynomial. So for some things that are not polynomials, that would be something like 3 radical x plus x squared minus 2. So this could also be rewritten as 3x to the 1/2 plus x squared minus 2, because we know the radical of the square root sign is a 1/2 exponent. So 1/2 here is not a positive whole number, so this is not a polynomial. And something like 2 over x squared minus 7x. So this is not a polynomial because we can rewrite 2 over x squared as 2x to the negative 2. Based on exponent rules. And once again, this exponent of negative 2 is not a positive whole number. And for the last one, something like 3x cubed plus 2x over 7x minus 8. So this is not a polynomial because of that huge division sign, that huge fraction that we have here. There's a polynomial in the numerator and polynomial in the denominator, but the whole thing itself is not a polynomial. This is actually something called a rational expression, which we'll be getting to. Okay, for the next three little definitions here, first one is a monomial. So a monomial is going to be a polynomial. It's a polynomial with one term. So that would be something like 4x cubed is a monomial because it just has that one term there. A binomial is a polynomial with two terms. So you just look at the prefix of the word to see what it's referring to. For example, something like 2x squared minus 4x. Binomial, we have two terms there. Lastly, we have a trinomial, which I'm sure you can guess is a polynomial with three terms. So that's going to be something like x squared minus 2x plus 5 is a trinomial. Okay, so getting into some of the operations, we'll start with adding and subtracting, go through it pretty quickly because we've already done it. So adding and subtracting polynomials is done by just combining like terms, which like I said, we've already done. So for example, let's add this first one, negative 9x cubed plus 7x squared minus 5x plus 3. We're going to add that whole polynomial to 13x cubed plus 2x squared minus 8x minus 6. So combining like terms here, so remember like terms have the same variable factors. So we have x cubed terms, negative 9 plus 13, that gives us 4x cubed. So those were those two. For the x squared term, 7x squared plus 2x squared gives us 9x squared. For the x terms, negative 5x plus negative 8x gives us negative 13x. And then lastly, 3 plus negative 6, 3 minus 6, we get minus 3. Okay, so just as easy as that, pretty simple. For the next one, we're subtracting. So once again, subtracting the cube terms, we have 7x cubed minus 2x cubed, which is 5x cubed. Negative 8x squared minus a negative 6x squared. So that's going to be plus 6x squared. So that means negative 8 plus 6, negative 2x squared. And then for the 9x minus negative 3x, that's 9x plus 3, so that's plus 12x. Lastly, negative 6 minus 9 is negative 15, so minus 15. Okay, so adding and subtracting polynomials is just combining like terms, so pretty simple. So now we'll get into the new-ish kind of thing, which we've already kind of done a little bit of in this beginning, is multiplying polynomials. So far, we're going to start with multiplying two monomials, so multiplying two polynomials with one term each in it. So we did this before. It's just using properties of exponents. So for example, let's do negative 8x to the 6th times 5x cubed. So all we have to do is multiply the negative 8 and the 5 till we get negative 40. And then we have to remember when we're multiplying common bases, we add the exponents. So 6 plus 3 for the new one, for the new exponent. So negative 40x to the 9th. So we're going to be using this concept for the next several things we'll be doing with multiplying polynomials. So we're going to be using, next we're going to be multiplying a monomial into a polynomial. And we're going to do that using the distributive property. So for this first one here, we have 2x squared times 3x squared minus 5. So we distribute that to both terms inside of here. 2x squared times 3x squared is 6x to the 4th. 2x squared times negative 5 is going to give us negative 10x squared. So we just distribute and then we use the exponent properties. So next one we have 3x to the 4th times 2x cubed minus 7x plus 3. So we have a monomial times a trinomial. So we distribute that in. 3x to the 4th times 2x cubed is going to give us 6x to the 7th. So we have to add the exponents. 3x to the 4th times negative 7x, negative 21x to the 5th. Add the exponents again. 3x to the 4th times 3 is plus 9x to the 4th. Okay, so let's make it, we'll be getting a little bit more complicated here as we go. So now we're going to be multiplying two binomials. So the product of two binomials, we're still going to be distributing each term. We're still going to be distributing, except we're going to be distributing each term from the first binomial to every term in the second binomial. So we also call this foiling. And we call it that because the F stands for the product of the first terms in each binomial. The O stands for the product of outside terms in each binomial. The I is the product of the inner terms, or the inside terms. And the L is the product of the second terms in each one, or the product of the last terms. So first, outer, inner, last for FOIL. So let's see some examples. So we have 3x plus 2 times 4x plus 5. So it's going to be the first terms multiplied together. And then it's going to be the outer terms multiplied together. And then the inner terms. And then these last terms. So it's just distributing, but we can call it foiling if we want. I just kind of recommend you thinking about it as distributing. So first one, 3x times 4x is 12x squared. 3x times 5 is 15x. 2 times 4x is 8x. And then 2 times 5 is 10. So all we're doing is multiplying every term from the first binomial into every term in the second one. So combining like terms here, we have 15x plus 8x. So that's 23x. So 12x squared plus 23x plus 10 is our final. Okay, next one we have 2x plus 4 times 5x minus 3. So multiplying first to first, then the outers, last, the inners, and then last to last. So first we have 2x times 5x, which is 10x squared. 2x times negative 3, we have negative 6x. And we have 4 times 5x, which is 20x. 4 times negative 3 minus 12. Combined like terms, we get 12x, or 10x squared. Negative 6x plus 20 gives us 14x, and then minus 12. Okay, and then for this next one, a little bit more complicated, and we have s's instead of x's. Doesn't really matter, still just a variable. So it's going to be multiply the first, multiply the outers, multiply the inners, multiply the last. 7s cubed times 4s squared is 28s to the 5th. 7s cubed times negative 3, that's minus 21s cubed. Negative 5s times 4s squared, negative 20s cubed. Negative 5s times negative 3 plus 15s. Combine those two middle terms again, we get 28s to the 5th. Minus 41s cubed after we combine like terms, plus that 15s, and we're done. Okay, so that's, so far we did a monomial into a monomial into a polynomial, and then two binomials. So now we're just going to kind of generalize it and do more. So to multiply polynomials with more terms, we just do exactly what we just did. We multiply each term from one polynomial by each term in the other polynomial, and then combine like terms. So like I said, the same thing we just did, except this is just technically not called foiling. It's just called distributing, so just distributing. So that's why I recommend you just thinking about foiling as distributing, because it's all just kind of the general same general idea. So the first one, multiply 2x plus 3 times x squared plus 4x plus 5. So we have a binomial times a trinomial. So we're going to multiply 2x into every term in here, and then we're going to multiply 3 into every term. So starting with the 2x, 2x times x squared is 2x cubed. 2x times 4x is 8x squared. 2x times 5 is 10x. 3 times x squared is 3x squared. 3 times 4x, 12x. 3 times 5, 15. So combining like terms, we have some squared terms and some x terms we have to combine. 8x squared plus 3x squared is 11x squared. 10x plus 12x is 22x. And then plus that 15, and it's written in descending order in terms of the exponents, so it's standard form, so we are done. Next one, 5x minus 2 times 3x squared minus 5x plus 4. So we're going to multiply 5x in, and then we're also going to multiply this negative 2 in. So just be careful with the plus or minus signs, I guess. So multiplying the 5x in, 5x times 3x squared is 15x cubed. 5x times negative 5x is going to be negative 25x squared. 5x times 4, 20x. Multiply that negative 2 throughout, we're going to get negative 6x squared plus 10x minus 8. Combine like terms, we have square terms and x terms again. We're going to get 15x cubed minus 31x squared plus 30x minus 8. And that's our final. Okay, and then for this last one here, before we move on to kind of shortcut ways to do some of these, we have a trinomial times a trinomial. So it's going to be the same exact concept. So multiply the first one into every one. Multiply the second one into every one. And then we're going to multiply the third one into every one also. So it's going to be a lot messier here. So multiplying r cubed in, r cubed times 2r squared is going to be 2r to the 5th. R cubed times negative r is minus r to the 4th. R cubed times 5 plus 5r cubed. Now we're going to multiply the 2r in, and we're going to get 4r cubed minus 2r squared plus 10r. And then we're going to multiply the negative 1 in, and we're going to get minus 2r squared plus r minus 5. So once again, just be careful with the positive and negative signs. Combine like terms, 2r to the 5th. We have only that r to the 5th term. We only have 1r to the 4th term. Combine the cube terms, we get plus 9r cubed. Combine the squared terms, we get negative 4r squared. Combine the r terms, we get plus 11r, and then minus that 5. And we're done with that one. Okay, so like I mentioned, there's going to be some shortcuts sometimes for how we do some of these. So when we multiply the sum and difference of two terms, that means we're multiplying a minus b times a plus b. What that ends up simplifying to is a squared minus b squared. So the reason for that, technically this is something you should memorize because it will come in handy when we do factoring. But if you forgot it, you can just take it and FOIL it out. So distribute a times b times a plus b. So multiply the a through, we get a squared plus ab. Multiply the negative b through, we get minus ab minus b squared. These middle terms cancel off, and we're left with a squared minus b squared. So that's why we can use that shortcut, because it'll always do that every single time. So let's do some examples here. We have x minus 3 times x plus 3. So let's use the shortcut. First, we recognize that it's going to be the same two terms. One is sum, one is difference. So that means it's the first one squared minus the second one squared. So x squared minus 3 squared, which is x squared minus 9. I'll put a little note over here, and I'll say, or you can FOIL it. Okay, and then for the next one, we have y plus 6 times y minus 6. Once again, we recognize the shortcut. It's the same two terms. One is sum, one is difference. So it's going to be the first one squared minus the second one squared, y squared minus 6 squared. That's y squared minus 36. And last one for this page, 5y plus 4 times 5y minus 4. A little bit harder, but it's going to be first one squared minus the second one squared. And notice that we had more than one factor for 5y. So I put parentheses around it, because now we have to use our exponent rules. We have to square the 5 and the y. So it's 25y squared minus 16. And now we're done. Okay, so that's a nice shortcut. Definitely try to have that memorized, because that will come in handy. So for the next little shortcuts here, we have a binomial squared, so the square of a binomial, if we have a plus b all squared, that's going to be a squared plus 2ab plus b squared. And if we have a minus b squared, it's the same thing, except with a negative sign on the middle term. So if you forgot about how to do this shortcut, you just use the fact that a plus b squared is a plus b times a plus b. You FOIL it out, you get a squared plus ab plus ab plus b squared. The two middle terms combine, you get a squared plus 2ab plus b squared. Then you could do the same thing for a minus b squared if you want also. Which I actually just threw in here for you. So a minus b all squared is a minus b times a minus b. FOIL it out and you get a squared minus 2ab plus b squared. Okay, so let's do these examples. Let's do this using the shortcut. So x plus 4 all squared, based on the shortcut right up here, it's going to be the first one squared, so x squared plus 2 times those terms being multiplied together. So plus 2 times 4x plus the second one squared. So it's x squared plus 8x plus 16. I'm just going to put another note here again, or FOIL it. Okay, so that's how you can do these ones in your head. So x plus 4 all squared, I would say I know the ending is going to be x squared for the left one. It's going to be 16 for the right one for 4 squared. The middle term is going to be 2 times both of them multiplied together, which gives it 8x. So just do not make the mistake of saying that x plus 4 all squared is x squared plus 16, because that would be wrong. So next one we have x minus 7 all squared. So it's the first one squared minus 2 times them multiplied together. And then it's going to be plus the last one squared. So x squared minus 14x plus 49. And last one here, we have 3m plus 5 all squared. So it's first one with parentheses squared plus 2 times them being multiplied together plus the last one squared. So it's 9m squared. 2 times 5 times 3 is going to be 30 plus 30m plus 25. Okay, and then for the next thing, so it gets a little bit more annoying here. We can have other exponents other than just 2. So we have a plus b cubed and a plus b to the 4th, and I just put a and so on. So to do these, there are other ways you can technically do them if you really wanted to. A plus b cubed is just a plus b multiplied together 3 times. So it's equal to a plus b times a plus b times a plus b. Similar thing for a plus b to the 4th. It's just a plus b multiplied together 4 times. So what you can do is just rewrite it, multiply them out 2 at a time until you get your answer. So this first one, we have x plus 4 cubed. So this equals x plus 4 times x plus 4 times x plus 4. So what I'm going to do is I'm going to multiply these two together first. X plus 4 times x plus 4 is x squared plus 8x plus 16. So you either FOIL it out or use that shortcut that we did previously. I'm actually going to rewrite the order for this. I'm going to rewrite that on the right hand side. So I'll say I'm multiplying these ones. So it's x plus 4 times x squared plus 8x plus 16. So it really doesn't matter the way you write it. I just prefer to write the polynomial that's smaller first. Okay, and then once we have this, we just multiply it like we did previously. We multiply the x throughout each term in the second one. We get x cubed plus 8x squared plus 16x. Multiply the 4 throughout. We get plus 4x squared plus 32x plus 64. Combine like terms, we get x cubed plus 12x squared plus 48x plus 64. Okay, next one we have x minus 2 to the fourth, so it's probably going to get a little messy. So to the fourth is x minus 2 times x minus 2 times x minus 2 times x minus 2. So what I'm going to do here is I'm going to multiply these two together, and then these two together, and then have two trinomials, and then multiply those together. So it won't be awful. So x minus 2 times x minus 2 is going to give us x squared minus 4x plus 4. And same thing with the other one, because they were the same things. And then we're going to multiply all three of these terms. So multiply the x squared throughout. Move this over a little bit. We get x squared times x squared. So x to the fourth minus 4x cubed plus 4x squared. Multiply the negative 4. We get negative 4x cubed plus 16x squared minus 16x. Lastly, multiply the 4 throughout. We get plus 4x squared minus 16x plus 16. Combine like terms, we get x to the fourth minus 8x cubed. I'm going to cross these off as I go so I don't miss anything. And then we have three different squared terms. So it's 24x squared. And then for the x terms, we have negative 16 minus 16, negative 32x. And lastly, for the 16, we just have plus 16. Okay, and that's it for that one. So let's do, I think, a couple more here. Do one more of these ones, actually. So we have negative 2r times r plus 2 cubed. So I'm going to rewrite this as negative 2r times r plus 2 times r plus 2 times r plus 2. So it was cubed, so I have three of them. And what I'm going to do is I'm going to multiply the last two of them together, the second, or the last two. So I'm going to multiply these two together real quick. R plus 2 times r plus 2 is going to be r squared plus 4r plus 4. So don't let the r's mess you up. And then I'm going to multiply r plus 2 into that. So I'm going to multiply this monomial last. I think that'll be the easiest. So multiplying the r plus 2 in there, we're going to get, so this is this whole thing. We're going to get r cubed plus 4r squared plus 4r. Multiply the 2 in there, we get plus 2r squared plus 8r plus 8. We have to combine like terms. That's going to give us r cubed plus 6r squared plus 12r plus 8. And now lastly, all we have to do is distribute the negative 2r. So distributing that negative 2r, we get negative 2r to the fourth minus 12r to the third minus 24r squared minus 16r, and we're done. So it looks pretty bad, but I mean, it only took less than a minute, so it wasn't awful. Okay, and then for the last thing here, I think like 2 more pages left. For the last thing, we're going to have polynomials with more than one variable this time. So let's say we're going to be using x and y as our with our variables in our polynomial. So it's going to have terms like a number a times x to the n times y to the m. So the constant a is the coefficient here. And the thing to keep in mind, the degree of a term with more than one variable, we have to add the degrees of the variables to get our total degree. And the degree of the polynomial is going to be the highest degree of all those terms. So for example, let's say we had something like 7x squared y cubed minus 17x to the fourth y squared plus xy minus 6y squared plus 9. So if we want to figure out the degree of the polynomial, we first have to figure out the degree of each one of these terms. So the degree of the first one is going to be 2 plus 3, so this is when we're adding the exponents. So 5. Degree of the second one is 4 plus 2, add the exponents, we get 6. Degree of the third one, they secretly have these exponents of 1 in here. Add them, we get 2. Degree of negative 6y squared is 2. The degree of a constant is 0. That is because we can rewrite that with an x to the 0 if we want, because x to the 0 is equal to 1. So that means the degree of the polynomial as a whole is going to be the largest one, which is 6. Okay, and we can, let's do some operations with polynomials with more than one variable. So let's start by adding and subtracting. So I won't spend too much time on this because all we have to do is combine like terms once again. And once again, recall that like terms are terms with the same variable factors raised to the same exponent. So we already did this, so I'll go through it pretty quickly. So let's subtract 5x cubed minus 9x squared y plus 3xy squared minus 4 minus 3x cubed minus 6x squared y minus 2xy squared plus 3. So combining like terms, and just be careful with the negatives, it's going to be 5x cubed minus 3x cubed, which is going to give us 2x cubed. And then it's going to be negative 9x squared minus a negative 6x squared. So minus a negative, so plus negative 9 plus 6, so minus 3x squared y. Next one, we have an xy squared term. So we have 3 of them minus negative 2, so 3 plus 2 is 5. So 5xy squared. And then lastly, we have this constant, negative 4 minus 3, negative 7. Okay, so that's just combining like terms. And for this last page here, let's multiply polynomials in two variables. So once again, we're doing the same multiplication rules we just did. We just have to take into account that there's more than one variable. So we have x plus 4y times 3x minus 5y. So we have two binomials, so you can consider it, call it foiling, but it's just distributing. So distribute the x into each term in the right one. X times 3x is 3x squared. X times negative 5y, negative 5xy. So I think I mentioned this. Make sure the coefficient is always first, so the number is first in the term. And then try to put the variables in alphabetical order, which is why I put the x first, before the y. Next, distribute the 4y in there, so we get 4y times 3x, so plus 12xy. 4y times negative 5y, negative 20y squared. Combine those like terms in the middle. 3x squared plus 7xy minus 20y squared. What I'm actually going to do here, just to be a little confusing, I'm going to put the y squared term second. So minus 20y squared plus 7xy. So it really doesn't matter in this case because the degree of each one of those terms is, every single one of those terms is degree 2. So it doesn't matter. I'm just doing it just because for this one. No apparent reason. Okay, for the last example here, we have 5x plus 3y squared. So let's rewrite this as 5x plus 3y times 5x plus 3y. And then you could FOIL it, or you could use the shortcut if you wanted to that we mentioned several pages ago, where it was the first one squared plus 2 times them being multiplied together plus the second one squared. Maybe I'll do that right after. So foiling this, multiply 5x to both terms, and then 3y. We're going to get 25x squared plus 15xy. And then multiply the 3y to both terms. We get plus 15xy plus 9y squared. Combine like terms, we get 25x squared plus 30xy plus 9y squared. And once again, I'm just going to, actually I'll leave it like that this time. It doesn't matter. Okay, and then I'll do it the other way right now too. So I'll say or 5x plus 3y all squared is going to equal the first term squared plus 2 times those terms being multiplied together plus the last term squared. So 5x squared, 25x squared. 2 times 5 times 3 is going to be 30. So 30xy. And the 3y all squared is 9y squared. So I guess it's a little bit shorter if you know the shortcut in this case, but either way, it's not awful. Okay, so that's it for P5.